I'm going to make this video as brief and straight to the point as possible, okay? For as long as we've studied the universe, the earliest chapter of cosmic history felt untouchable. It was an age swallowed in darkness, too young, too chaotic, and too empty for anything remarkable to exist. We believed the story of the early universe was a simple one, a period of darkness followed by a slow, predictable dawn. But deep in that cosmic dawn, an era where we thought complex structures couldn't exist, the James Webb Space Telescope has found something that challenges our models of the universe. An object so bright, so mature, and so full of the building blocks for life that, according to our current understanding, it just shouldn't exist. Right now, Webb's discoveries are forcing scientists to think that they may have gotten the beginning of the universe completely wrong, and I will be breaking that down for you as we move forward. So, why is this so profound? Let's think about the moments after the Big Bang. For the first 380,000 years, the universe was a hot, opaque soup of particles where light was trapped. Eventually, it cooled down enough for the first atoms, mostly hydrogen, to form. But this created a new problem. The universe was now filled with a thick fog of neutral hydrogen gas that blocked all light. This period is what we call the cosmic dark ages. For hundreds of millions of years, there were no stars, no galaxies, just an expanding darkness. Our models, the simulations that form the foundation of our understanding, predicted that the end of this era, the cosmic dawn, began when the very first stars ignited. They predicted this would be a slow, gradual process. Gravity would patiently pull the primordial gas into small, simple proto-galaxies. These first stars would take a very long time to assemble into the grand structures we see today. For all of history, that first chapter was a mystery, locked away by time. That is, until now. The Webb Telescope isn't just an observatory, it's a time machine. Because light takes time to travel, looking at the most distant objects is the same as looking back in time. Webb was built for one primary purpose: to see the end of the cosmic dark ages and witness that very first light. The light from those first galaxies has been traveling for over 13.5 billion years, and the expansion of the universe has stretched it into the infrared spectrum, the very light Webb is designed to see. An international team, as part of the JADES program, pointed Webb at a tiny patch of sky, hunting for the faintest, reddest smudges imaginable. And in January 2024, they found one that broke every record, a tiny red blob named JADES GSZ140. They confirmed its redshift, a measure of its distance, at a staggering 14.32. They had successfully peered into the cosmic dawn, but what they saw wasn't what they expected. This wasn't some faint, chaotic cluster of first-generation stars. JADES GSZ140 was astonishingly bright, far more luminous than any of our theories predicted for a galaxy at this age. The universe, it seems, got to work building brilliant galaxies much faster than we thought. In fact, Webb is finding that these bright, early galaxies are more than 10 times more numerous than pre-Webb observations had suggested. But the real shock came when scientists analyzed the chemical footprint hidden in the galaxy's light. They found the unmistakable signature of oxygen. Now, this is a profound puzzle. The Big Bang only created hydrogen, helium, and a little lithium. Every other element, what astronomers call metals, is forged inside stars and scattered only when those stars die. To find oxygen this early means at least one full generation of massive stars had to be born, live their entire lives, and explode, seeding the next generation. Finding oxygen this early is like finding a fully grown adult in a nursery. It suggests this galaxy was already chemically mature at a time we thought no galaxies should be. So, what does all of this mean? As one researcher, Jake Helton, put it, JD's GSZ 140 is not like the types of galaxies that have been predicted by theoretical models and computer simulations to exist in the very early universe. This isn't a minor tweak. A chasm is growing between theory and observation. Our models of slow, gradual galaxy formation are simply too gentle. Scientists are now scrambling to figure out how this happened. Do our theories of how dark matter collapses to form the seeds of galaxies need a revision? Perhaps the first stars were far more massive, living fast and dying young to enrich their galaxies at a breakneck pace. Some more exotic ideas are also on the table, like dark stars, powered by dark matter annihilation, which could explain the extreme brightness of some early objects. These are fundamental questions about the physics that governed the dawn of time. JD's GSZ 140 is also giving us our first real glimpse into the epoch of reionization. The powerful radiation pouring from these bright early galaxies is what burned through the fog of neutral hydrogen, making the universe transparent and ending the cosmic dark ages for good. The story of JD's GSZ 140 is a perfect example of what makes science so exciting. We build a revolutionary tool, point it at the unknown, and hope to be surprised. As MIT's Rohan Naidu, a lead researcher on early galaxy discoveries, said, "It looks nothing like what we predicted, which is both challenging and exciting." JD's GSZ 140 held the record for a time, but in the fast-moving world of Webb science, that record has already been broken. Astronomers have now confirmed a galaxy called MOM Z14, which we are seeing just 280 million years after the Big Bang. And just like its predecessor, it is brighter and more chemically enriched with elements like nitrogen than our theories predicted. It's clear these impossible galaxies are not flukes. They are the new reality. Webb has opened a window onto a chapter of cosmic history we could previously only dream of, and it has found that the story is richer and more spectacular than we dared to imagine. The darkness is broken, and the secrets hidden for over 13.5 billion years are finally coming into the light. If you finish this video, don't forget to comment on what you think about these discoveries. Is this a sign that our cosmological models need a complete overhaul? Or is there a piece of the puzzle we're just not seeing yet? Thanks for watching.